Hello everyone, I'm Roshna Devi and along with my teammate Lohit Narayan, we are presenting our project titled AI Powered Personal Memory Assistant. This project is developed under the guidance of our mentor, Ms. Aishwarya, in the domain of artificial intelligence and machine learning. Today, we are excited to present how our project aims to support individuals suffering from Alzheimer's disease and other cognitive disorders using artificial intelligence technologies. Coming to the problem statement, Alzheimer's disease and dementia affect millions of people worldwide. Patients often forget names, medication timings, appointments, and even important daily activities. This creates confusion, emotional stress, and dependency on caregivers. Existing reminder systems and note taking applications are not intelligent enough to provide personalized and adaptive support. They are mostly depend on manual interaction and cannot understand user behavior or changing cognitive conditions. To address this issue, we developed an AI powered personal memory assistant that acts as a digital memory companion. It helps patients remember important information, receive timely reminders, and improve their independence in daily life. Now, introduction. Our personal memory assistant is an intelligent system designed to capture, store, and retrieve personal information in a context aware manner. Unlike ordinary reminder apps, our system uses technologies like natural language processing, speech to text, text to speech, facial recognition, and adaptive learning. The assistant can recognize people, remind users about medications and appointments, and provide personalized support according to the user behavior and habits. This not only improves the patient's quality of life, but also reduces the burden on caregivers. While developing this project, we identified several important challenges. First, collecting accurate personal information without requiring constant manual input was difficult. Second, the system had to provide the correct information at the right time using contextual understanding. Another challenge was adapting the system according to progressive cognitive decline in patients. We also focused heavily on data privacy and security because healthcare information is highly sensitive. Finally, the system had to remain simple and user friendly for elderly users and caregivers. The motivation behind our project comes from the growing need for intelligent healthcare assistance. Traditional reminder systems are limited because they lack personalization and contextual awareness. Patients with Alzheimer's disease require continuous support to manage daily routines safely. At the same time, caregivers experience physical and emotional stress due to constant supervision. Our solution aims to bridge this gap by offering adaptive memory recall, intelligent reminders, and personalized assistance through AI technologies. To build a strong foundation of our project, we studied multiple recent research papers related to AI in dementia care and memory assistant. One research paper explored AI powered virtual assistants for older adults and showed that LLM based assistants provide more accurate and informative responses. Another paper discussed speech-based detection of Alzheimer's disease using machine learning and deep learning models such as CNN, LSTM, and BERT. We also studied socially assistive robots and explainable AI systems used in dementia care. Additionally, papers related to facial recognition and speech-to-text technologies helped us understand how AI can improve cognitive assistance in real-time applications. These studies inspired the design and implementation of our proposed system. Our proposed system is an AI-powered personal memory assistant specifically designed for Alzheimer's and dementia patients. The system captures and stores personal information securely. It uses speech to text technology to process voice commands and facial recognition to identify people and help patients recall names. The assistant provides reminders through voice prompts and mobile notifications. We also implemented adaptive learning so the system can personalize reminders based on user habits and behavior patterns. Additionally, caregivers can monitor important activities and receive alerts when critical tasks are missed. Coming to the architecture diagram. The architecture of our system includes multiple integrated models working together. The user interacts with the system through voice commands, text inputs, and camera input. The data is processed using AI technologies such as NLP, facial recognition, and speech processing. The processed information is securely stored in the database, and intelligent reminders are generated based on contextual analysis and user behavior. Expected outcomes. Our system is expected to improve memory recall for users by helping them remember names, appointments, and important events. It also provides personalized assistance through adaptive reminders. Another major outcome is reducing caregiver burden through automated notifications and monitoring. Facial recognition helps improve social interaction by assisting patients in recognizing family members and caregivers. Overall, the system supports better routine management and improves the quality of life for dementia patients. System requirements and tools. For hardware requirements, we use a laptop or PC with at least an Intel i5 processor, 8 GB RAM, and a camera and a microphone for facial recognition and voice input. On the software side, we use technologies like Node.js and Express for backend development, React Native or Flutter for front-end applications, MySQL, Firebase, and MongoDB for database management, OpenCV for facial recognition, and speech processing APIs for voice interaction. We also use machine learning libraries like TensorFlow and PyTorch for AI functionalities. Modules and description. A project consists of several important modules. The data collection module captures voice, text, and emoji inputs. The speech to text and NLP module converts voice into text and extracts important information. The facial recognition module identifies family members and caregivers using camera input. The database management module stores reminders, contacts, and contextual information securely. The reminder and notification module generates smart reminders and alerts. Finally, the personalization and learning module continuously adapts according to user habits and behavior. Coming to the implementation. In the implementation phase, we developed multiple interfaces and functionalities for the system. This includes user authentication, memory management, caregiver monitoring, routine scheduling, facial recognition, and speech to text assistant. The system runs locally and demonstrates real-time interaction between AI modules and the user interface. Now, I'll be demonstrating the implementation of our project using Visual Studio Code and our working application. First, this is the project structure inside VS Code where we develop both the front-end and back-end for our project. For the front end, we use technologies like HTML, CSS, JavaScript, and React-based components to create a simple and user-friendly interface suitable for elderly users and caregivers. For the backend, we use Node.js and database connectivity to manage user data, reminders, routines, and memory-related information securely. We have the authentication page where the user or caregiver can securely log into the system. Authentication is important because patient information and healthcare data are sensitive and must be protected from unauthorized access. After successful login, the user is redirected to the homepage dashboard. This is the main homepage of our application. From here, users can navigate to different models such as routines, my people, memories, find my things, caregiver support, and facial recognition and speech to text assistant. In the routine section, users can add and manage daily activities such as medication schedules, doctor appointments, meal timings, and important information.
Great job. You completed. Wake up.
This module helps user remember important This module helps users remember important people in their lives. Family members, friends, caregivers can be added along with their photos and details. Using facial recognition, the system identifies the person and helps the patient recall names and relationships. The memories section stores important personal information, events, notes, and reminders. Users can easily retrieve stored memories whenever needed. This acts like a digital memory extension for Alzheimer's patients. This module helps users remember where important objects were kept. For example, patients can store notes like I kept my keys on the dining table. Later, the assistant helps retrieve that information instantly. This reduces frustration caused by forgetfulness. Caregiver dashboard. This section is specifically designed for caregivers. Caregivers can monitor patient activities, reminders, and missed tasks. The system can also send alerts if the critical routines or medications are missed. They can also add someone as a SOS contact so that the SOS will automatically send a WhatsApp message to the particular person. Here we demonstrate facial recognition functionality. The camera captures the user face and identifies stored contacts using AI-based recognition techniques. This feature is specifically useful for helping Alzheimer's patients recognize family members and caregivers. We implemented this using computer vision libraries such as OpenCV. Speech-to-text voice assistant. This is a speech-to-text voice assistant feature. This user can speak naturally and the system converts speech into text using speech recognition APIs. The assistant understands commands and provides personalized responses and reminders. This allows elderly users to interact with the system easily without typing.
Good afternoon, Devi. I am your memory assistant. I am here to help you. How are you feeling today?
Backend and database. Now moving to the backend implementation, we manage user authentication, reminder scheduling, memory storage, caregiver notifications, and facial recognition data. Overall, our project combines AI, speech processing, facial recognition, adaptive assistance into a single platform designed to support Alzheimer's and dementia patients. Our goal is to improve independence, reduce caregiver stress, and enhance quality of life through intelligent memory assistance. Thank you for watching.